Hey everybody, so I want to show you how to apply the curve fits that I want you to use in order to make your graphs for the analysis homework. So I have posted an example analysis, what I want it to end up looking like as you answer the different questions. In there, they're asking you to make or apply several different curve fits. So for the position graph, I'll go through the three fits that you will be using in this analysis and the different graphs you're using them in. So for position versus time graph, in order to determine acceleration, you're going to highlight the region where the cart was freely moving without your hand pushing it. And then in order to make a curve fit, you're gonna go down here where it says Graph Tools. You're gonna apply a curve fit, and then you're gonna go quadratic on it. Now here in this, your y equals ax squared plus bx plus c formula. The a value here is equivalent to 1/2 of your acceleration value. So this is a constant which represents 1/2 acceleration in your formula for straight line motion with uniformly accelerated motion. So you just multiply this value by 2 to get your acceleration value. So that's the quadratic curve fit. With the velocity versus time graph in this one, you're going to do a linear curve fit. Again, though, you want to select the region where your hand is not touching it and where it hasn't yet hit the barrier. You apply a linear curve fit. Here, your m value, your slope value, is your acceleration, 0.2899. And you'll see in your data as well, hopefully, that your slope value is very similar to 2 times your a value in the quadratic curve fit before. All right, and last one you're going to need to do is acceleration. For this one, again, you select the region by clicking and dragging. You go down here, but instead of doing curve fit, you're finding the mean average for your y value across that range. Your mean then is given in meters per second squared. So your average acceleration between this point at like 0.8 seconds to this point at 4.25 seconds, here we go, 0.9 to 4.15 is 0.288 meters per second squared, which again is very similar to the slope and very similar to the acceleration from the quadratic equation. And those are 3 values that you're writing down just like I have it in the example Google document. In addition, I want to show you how to work with the second run with the bumps. Whoops, I don't want both. I just want run 2. Here, select 2 bumps and make 2 linear fits in order to find the slope and compare them. That's what you're doing for the part 2 analysis. You're doing 2 separate linear fits. And you can see they're pretty different. Granted, I haven't really selected the region over here too well. And then whoops, same thing for position. You're selecting the free motion range, and oh, it selected that for me. Well, that's not what I wanted. Select your range, apply curve fit, quadratic, and then you're doing it again over here. Same thing. Apply curve fit quadratic. Cool. And then you can compare your values 0.1426 and 0.144. Not the best. The ones I have in the Google Doc are a little better for this data, but that's okay. And again, you're comparing. And as long as you're within 2 significant figures, that's precise enough. So as long as 2 significant figures agree, then I would call it good. The first thing I asked you to do in part 1's analysis is to identify some regions. In order to do that, there's a couple ways to do it. A couple ways you can highlight that region and then export it, which I'll show you in a second. Or you can add an annotation, which is nice and easy. So pushed by hand. And then I've done that for both velocity and acceleration at the same time by setting it up like this. Now, if you want to be really smart, you could do this. Push by hand and then just overlay acceleration. And see that it covers the same region. Going up the hill here and then add an annotation. And then same thing on this side. Downhill. Okay, now every time I did this, in order to take this image and put it into Google Docs, I went here and exported it as a graph image. And then that will save it as a portable net graphic, a PNG file, which you can then insert into your Google Doc by clicking Insert Image and uploading it from your computer. So that's how I got them all in there. Now for part 2, questions 5 and 6 there, just put in the data. Don't worry about trying to get graphs for those. Okay, if you have questions about this process and how to do it, send me an email. We'll also touch base on Monday and go from there. So thanks everybody. Have a great weekend. Bye.